Okay, let's dive right into this explainer and uncover the highly technical, completely hidden world of architectural acoustics. We're going to look at the actual invisible engineering that separates a truly luxurious space from one that, well, just looks the part. It's a universally relatable experience, right? You walk into this gorgeous modern room. Maybe it's a high-end restaurant, a super sleek office, or one of those luxury minimalist apartments, only to be totally overwhelmed by a chaotic echo. You literally can't hear the person sitting across from you, and every single footstep just rings out. Sure, it looks absolutely beautiful, but man, it feels exhausting to be in. That disconnect, that's exactly what we're exploring today. So here's how we're going to solve this mystery over the next few minutes. First, the modern acoustic dilemma. Then, isolation versus absorption. Next up, invisible acoustic solutions. After that, active noise cancellation. And finally, acoustics in action.
All right, part 1, the modern acoustic dilemma and the design challenges we're facing today.
So, modern architectural trends absolutely love open concepts and these hard, highly reflective surfaces. Think glass, concrete, marble. But honestly, these materials are a total acoustic nightmare. On top of that, as acoustic experts from the Walter Storick Design Group point out, the pandemic drove this massive boom in what they call the e-studio. Suddenly, everybody needed mission control level remote working and entertainment spaces right at home. And we all quickly discovered that thin walls in luxury apartments, yeah, they completely ruined that experience. I mean, you can't run a global meeting or enjoy a high-end home cinema for that matter if your room sounds like you're sitting inside a tin can.
Moving on to part 2, isolation versus absorption. Let's demystify the physics a bit.
To actually fix a loud room, we have to understand the physics at play. Acoustics is literally a subfield of physics. It's all about how sound energy behaves, reflects, absorbs, and diffuses in a given environment. You see, a lot of people try to fix a bad-sounding room by throwing money at it, buying crazy expensive speakers with electronic room correction software. But as the experts at WSDG brilliantly note, trying to fix physical acoustic flaws with electronic room correction, well, it's basically like putting a Ferrari engine on Toyota wheels. If your room has slap echoes and crazy reverberation, pumping more electronic energy into it just makes the whole problem worse. You have to fix the physical room itself.
So here's the absolute crucial takeaway. You need to understand the difference between isolation and absorption. Acoustic isolation is all about stopping sound transmission through walls. It's keeping your neighbor's noise out, which one engineer hilariously described as stopping Godzilla's footsteps from waking you up at night, and it's keeping your own noise in. Absorption, on the flip side, is about managing the sound reflections inside the room to kill those echoes and make conversations crystal clear. You really need both for a space to feel truly comfortable.
All right, part 3, invisible acoustic solutions. This is where the hidden engineering gets really cool. We have a staggering arsenal of hidden solutions today. You really don't have to glue those ugly foam egg crates to your walls anymore, thankfully. Designers are using things like micro-perforated wood. These are stunning panels with tiny half-millimeter holes that literally swallow sound, but to the naked eye, they just look like solid timber hung up on simple Z-clips. Then there's acoustic plaster. This stuff applies like a smooth, natural mineral surface, but it completely hides extreme sound-absorbing capabilities. And behind the drywall, engineers are using heavy, mass-loaded vinyl membranes and resilient channels to physically decouple the walls from the building's skeleton. It's like building a room within a room. The real power of these hidden materials all comes down to the math. Systems like the ones from Invisible Acoustics achieve an incredible noise reduction coefficient, or NRC rating, of 0.90. To put that into perspective, it means that when sound hits what looks like a perfectly flat, solid ceiling, 90% of that reverberating sound energy is completely absorbed. Only 10% bounces back into the room. And the craziest part? They pull this off without showing a single visible seam. It's basically magic, but, it's physics.
On to part 4, active noise cancellation and how this shapes the future of urban living.
As our cities get denser, city noise is becoming a massive problem. And guess what the absolute hardest noise to block is? It's that 50 to 500 Hz frequency range. That is the exact low-frequency, deep rumble of urban traffic, aircraft flyovers, and heavy machinery. Standard multi-pane windows really struggle to block this out. But, get this, emerging active noise cancellation, or ANC systems for buildings, can reduce this perceived noise by an impressive 10 to 15 decibels. That is a massive reduction. And you don't even need a complete building overhaul to do it. Here's exactly how that tech works.
First, an exterior microphone on the window detects the incoming urban noise. Second, a digital signal processor analyzes the sound's frequency and phase. Third, an interior speaker array generates the exact inverse sound wave. And finally, when those two opposing waves meet, they create destructive interference. Basically, they cancel the noise out completely. The system acts as this invisible electronic shield, creating a mirror image of the sound wave to destroy city noise right at the glass before it even enters your home. How insanely cool is that science?
And finally, Part 5, Acoustics in Action. Let's look at the reality of retrofitting penthouses. To really ground all these concepts, let's talk about the utter logistical nightmare of retrofitting high-rise luxury penthouses. Because they sit at the very top of a building, penthouses are often directly underneath rooftop bars, pool decks, or huge rattling mechanical equipment. Let me give you an example. In one case study from Commercial Acoustics in Clearwater, Florida, a penthouse was suffering from the noise of a rooftop bar right above it. Now, the textbook acoustic fix is to just treat the floor of the bar, but you cannot tear up a rooftop deck without breaking the building's waterproof envelope. The risk of catastrophic water damage is just way too high. So the engineers were forced to do a ceiling retrofit from below. They had to work entirely inside the penthouse using a super heavy mass-loaded membrane called Wall Blocker Pro. Honestly, working on a penthouse is an intense engineering challenge. According to Vancouver builders Enzo Design Build, penthouse renovations usually carry a 20 to 30% altitude tax. Why? Well, because you are fighting intense structural physics. High-rise floor slabs have really strict live load weight limits. If you want a heavy luxury finish, say marble floors, or maybe a hot tub, you have to build custom steel dunnage frames just to distribute that weight safely. Plus, you have to battle high-altitude wind shear. You have to hire massive street-blocking cranes to hoist up materials that simply won't fit in the tiny service elevators. And on top of all that, you have to pass incredibly strict Strata Council acoustic approvals just to prove you won't ruin the quiet for the neighbors living below you. It is a whole ordeal. To actually pull this off, engineers have some very exact targets they need to hit. They use a metric called Sound Transmission Class, or STC, which measures airborne sound blocking. To successfully combat that loud rooftop bar we talked about, you absolutely must hit an STC of 60 or higher. For that Clearwater penthouse, hitting that number meant meticulously applying heavy sound membranes continuously across every single flat surface, and carefully wrapping it through every ceiling soffit. If you miss even one tiny gap, the sound just flanks the treatment. It sneaks right around it, and suddenly your multi-million-dollar view is completely ruined by the thumping bass from the party upstairs.
Ultimately, the greatest success in architectural acoustics is creating a perfectly serene environment where all of this heavy, complex engineering just vanishes. It vanishes completely into the design. Whether we're talking about microperforated wood, hidden mass-loaded vinyl, or crazy futuristic electronic noise-canceling windows, the goal is always exactly the same: to create a space that feels every bit as beautifully calm as it looks.
It really makes you wonder about the hidden soundscape of your own home, doesn't it? The next time you walk into a perfectly tranquil space high above a chaotic, noisy city, take a second to look at the ceilings and the walls, because you are more than likely surrounded by thousands of pounds of invisible acoustic engineering working silently right behind the paint to protect your peace. It kind of makes you wonder, right? What other invisible forces have been engineered into the spaces you inhabit every single day? Thanks for joining me on this explainer, and keep looking for the hidden science in the world around you.